Hello everyone. We're looking at types of substances, including metals, and how the atoms in metals bond together very strongly, the properties of metals, and how we can change metals by using alloys or heat treatment. Metals tend to lose their valence electron, that's their outside electron, so they become a positively charged ion called a cation. The cations are arranged in three-dimensional lattice. That means we have the atoms lined up. They line up and down like this, back and forward like that, and left and right like that. That's a three-dimensional lattice. And when the atoms are like that, they're kind of locked in place pretty well. They can't move around much. So that's a very strong arrangement. The valence electrons that the atoms lose, they don't just disappear. They kind of become a bit of a sea of electrons or a fog of electrons that move around. They're delocalized, which means they don't have any particular place. They can move all around like this. And there's an electrostatic attraction between the positively charged metal cations and the free electrons. They stick together closely, but that doesn't mean the electrons are stuck. They can move around even though there's still a strong force of attraction between them, and that holds the metal together overall. There's several common properties to metals. One is that they are good conductors of electricity and heat. So here's a picture of some electric wires. Metals can be polished to get a good shine. That's called a metallic luster. And also metals are malleable, which means they can be hammered into shape. Now there's reasons why these things happen. If I put a positive, let's say a negative charge over here, and a positive charge over here, electric positive charge over this side, the electrons are free to move away from this side. So more electrons can come in this side, and the electrons are free to move all along, and the electrons can go at this side. So when electrons are free to move, that's an electric current. Also, the metals can be shiny because we can actually polish off this side of the metal very closely, and we get the electrons. They form a bit of they sort of fill in the gaps. They form a bit of a seal over the top, a bit like a bit of a paint over the top, and any light coming in like that can just reflect straight off, so the metal is nice and shiny. Also the malleable, okay? Metals are malleable. I can hammer this metal down and I can move all these atoms around, and they can move up maybe over here somewhere, but that doesn't necessarily break the bonds. So the metal still holds together even though I change its shape. That's because of the way the cations in this 3D lattice held together by the delocalized electrons. Now, sometimes we don't want the pure metal. Well, it's got some characteristics which we don't like. For example, if we look at steel, here's a spoon. If this was an iron spoon, it would go rusty. But we want to have a stainless material. We don't want it to go rusty, so we want to change the properties. What we do is we melt the metal, then we put some other materials into the metal, and they dissolve into the molten metal. When the molten metal cools down and turns back into a solid, the other atoms that we added, they're trapped inside, and it changes the characteristics of the metal. For example, maybe it'll be harder. So here's some gold. Gold's a great thing for jewelry, but it's actually quite soft, and it will get dinted and scratched, and it won't look quite so good. It'll lose its shine a little bit because it's so scratched up. We might want to make it stronger or improve the appearance of the gold. Now, there's a couple of different kinds of alloys. One is the interstitial alloy. Now, interstitial just means in the gap. And here I've got a diagram of some iron, and into the iron we've put some carbon atoms. There's one there, there's a carbon atom there. All these blue ones are iron atoms, and there's another carbon. And the carbon atoms are small enough, they fit in the gaps between the iron atoms. And what that does is it slightly stretches the structure of the iron and makes it fairly rigid, and then it becomes much harder. So steel is much harder than iron. It's got different properties. It's stronger than regular iron. That's because of these carbon atoms shoved in there in all the little gaps, not every gap, but in some of the gaps the carbon is in the gaps between the iron. That's called an interstitial alloy. It improves the properties of the metal. Another kind of alloy is substitution alloy. Now, if the atoms that we add are about the same size or maybe a little bit bigger than the original atom, so if this was maybe iron here, that's like Fe for iron, Fe for iron. Now, what if this one was a nickel atom? What if it was slightly larger than the iron atom? Okay, so what it's going to do, the nickel ions are going to like stretch the lattice again, stretch the crystal of the iron, and it's going to make a bit of a like pressure on it, and that makes it more rigid, and then it can't move, and so it's got a different property. Also, if some of these got like corroded away and we had a whole bunch of nickel atoms just here that were left over, the nickel atoms, they don't corrode very well, so we're going to get a nice shiny pot that we can shine up, maybe get a little bit of rusty spots on it. We can just shine that up and have a nice shiny stainless steel, which is nice and strong, and that's the substitution alloy stainless steel, which has nickel added to the iron. Now, we can also treat metal in a certain way, so we change its properties by giving a heat treatment. Now, if we heat the metal right up to a high temperature, the grains or the crystals inside the iron, they're going to grow larger. Then if we cool it down slowly, the grains remain large. And so the metal then stays pretty soft because those large crystals can move around and the metal can bend and it's soft. If we take that hot metal and very quickly cool it down by plunging it into some water, the crystal structure changes and the crystals are quite small. And this gives a much harder metal, much more brittle. Now, hard and strong is good, but maybe brittle is not good. So what we can do then is warm up the metal again, just to warm it up a little bit, not to melt it. The crystals remain small, but the internal stresses are relieved. So what we get is a metal that's medium hard, medium hard metal, and it's strong but not brittle. And so you can imagine that if we had maybe parts in an engine, here's some big cogs in this engine and some small cogs. We don't want those to break, but we don't want them to bend either. So we want it both fairly hard but not brittle. And so a lot of these engine parts, they get heat treated by tempering, and that gives it the correct properties. So as you can imagine, we can change the properties of metals in a couple of different ways. We can do alloying, we can do various kind of heat treatment, and it gives us the properties that we want.